Hello everyone, my name is Barbara and I would like to welcome you all to our latest Novedge Webinar episode. In this week's episode, importing and using scan meshes into SolidWorks with power surfacing reverse engineering from npower software. Power Surfacing RE provides tool for importing and reverse engineering scan meshes into SolidWorks and using that scan data for design, analysis, 3D printing, and so on. Today's presenter, Sue Blackman, is a 3D artist, author, and educator. She has taught classes in the engineering and drafting departments of top-rated community colleges and as author for Apress, Lynda.com, and AMC Siggraph. Before we get going, here's an overview of what we do at Novedge. Novedge is one of the largest online stores for design software, and we offer a huge assortment of software solutions that cater to virtually every designer's need. Put us to the test and come visit our webpage at novedge.com. And for more daily software news and limited time promotions, pay a visit to the Novedge blog, to our Facebook page, Google+, and Twitter accounts. Coming up next week, Introduction to Atlantis 6. Join us to learn about the latest version of Atlantis, which boasts its own built-in physical engine. Last but not least, today's webinar is free and is being recorded live. So if you want to rewatch this or any webinar episode in our collection, just head on over to Novedge's YouTube or Vimeo channels. And now I'm going to pass the baton and share the screen with Sue and David for their exciting presentation. I think the screen is transitioning. Okay. Take it away.
Right, welcome, everyone. We're excited to show you our Power Surfacing RE product. We're excited to have so many people here to view it. And we're representing IntegrityWare and Power Software. And we're going to tell you about Power Surfacing RE, which is built on top of our award-winning Power Surfacing product and is a reverse engineering product targeted specifically for SolidWorks and integrated with SolidWorks. Power Surfacing has won awards at the last two SolidWorks World events, winning the best software solution or being chosen as the best software solution each of the last 2 years. So we're pretty excited about that, but we think Power Surfacing RE is even more exciting as a product. What Power Surfacing RE does is it allows you to import polygon models in OBJ or STL format from things like scanners, from finite element modeling systems, from 3D sculpting products, from 3D print files, or from other polygon modeling tools. It also allows you to reverse engineer SolidWorks surfaces and solids and use them in a way that's very easy and intuitive. I know that some can struggle with modifying SolidWorks surfaces, but this makes it an easy way to modify that type of geometry. Also, we can constrain to and reference the imported geometry, the scan meshes or the SolidWorks surfaces and solids, and therefore we can preserve the original design shape and we can support variations of that shape. So you can put handles on things, you can put a scoop on a car or a fin on the back of it, or things like that. Or you can change the size and shape of the object after you've turned it into a power surfacing object. Another nice tool that we have is, we know you want to be able to fill holes in your mesh geometry, but you also want to be able to preserve the continuity or curvature of the surface that hole is in. So we have a nice tool that allows you to patch holes while maintaining the surface curvature. We also have a very exciting tool that does essentially shrink wraps the geometry to the imported mesh so that it basically sucks down to the exact size or pretty close to the precise size of the actual geometry. And you can control the quality or the accuracy of that shrink wrapping. And then we also provide an interactive tool for comparing the accuracy in a color-coded manner of the geometry against the imported geometry that you're referencing. One of the nice things about Power Surfacing RE is that it's truly integrated into SolidWorks, and it creates native SolidWorks geometry so that you can apply shells or fillets or booleans or any other SolidWorks command to the geometry, or you can run analysis or CAM or finite element modeling, or do 3D printing from it. In fact, one of the nice things you can do with Power Surfacing RE is you can import scan meshes and then modify them and do nice 3D prints. And because it creates Class A surfaces automatically, you get a very nice smooth surface, and it creates watertight solids which are very suitable for 3D printing and avoid some of the problems with that type of medium. What are some of the workflows that people are using Power Surfacing RE for? Probably the most common is to reverse engineer scan parts and then take those parts and output them to other CAD systems, or just use them within the SolidWorks environment. Another thing you can do is simplify your CAD model and make it easier to modify the geometry, even if you don't have the command history. So you can push it and pull it and add geometry to it and modify it in easy ways rather than difficult commands. You can also use it to repurpose a very complex model and make a simpler version which is suitable for analysis or simulation. And at the same time, you can preserve or maintain the shape and dimension of your geometry. So you can really get a faster result that's that is accurate. One of our customers that's using Power Surfacing RE and absolutely loving it is Ron Ogletree at Sabre Racing. What they do is they design NASCAR cars, and they start with an original stock car and they turn it into a racing car. And Ron told me that his design process has gone from a typical eight-month process down to 6 weeks. And because of that, they've been able to do a greater amount of work and actually branch off into other things as well. Here's an example model that they use. On the bottom, you see a standard Corvette model, stock Corvette. And on the top, you see their redesigned NASCAR version of the Corvette. And they use it to run flow analysis, as you can see in the image. So in this process, they take the original geometry, which you can see in gray, and then they create the Power Surfacing RE representation in a sub-D version. And then you can see what they do is they then change the shape. They may, for instance, you can see the difference in the wheel well areas. They generally shrink it down closer to the ground, and in some cases they shorten or elongate the car and put fins on it and scoops and stuff like that. Then they take and explode the views of different areas of the car, and then they break it down into manufacturable sections so that they manufacture each of these pieces separately, and then they lock them together with bolt locks. And you can see, if you look closely, the little bolt lock sections across each of the broken out sections. Here's a breakout of each of those manufacturable sections for the car. And here's the final version, and this one you can clearly see where the lock pieces are across the seams. And so there's the customized racing version of the car that they produce. So Power Surfacing RE, here's kind of what it looks like, and you see it's a very similar integrated SolidWorks environment that looks and feels very much like the standard SolidWorks environment. So it should feel very familiar to you as you're using it and learning it. And now I'm going to turn the time over to Sue Blackman, who's our fabulous demo person, and she's going to show you Power Surfacing RE.
Go down to
this one or that one right there, right?
Yep.
Okay, everyone should be able to see the SolidWorks screen right now.
Yes, we do. Yes, we do.
Okay, so I'm going to start out by showing you guys the tools, because it's one thing to see pictures of the finished result, but everyone always wants to see, well, just how easy is it going to be to use. So I'm going to find my cursor here. I'm going to open an OBJ file, but OBJs can be opened as either sub-Ds or they can be opened as reference mesh. So I have to make sure and tell it I want to see the reference mesh when I import. And I'm going to start with our usual detergent bottle here because it's kind of nice to work on. And get it aligned here and bring it in. And in the Power Surfacing RE tab, you'll see that we have several tools here. I'm just going to go over a few of them. Probably the most useful is Draw Edges. And it works like this. You click to create a quad because sub-Ds love quads.
And notice that it snaps to the reference geometry.
And it sort of completes them as you go. So it's pretty quick. And I think that's the most useful one of the tools that you'll find using most often. Another one, so I'll right-click here, delete this guy. Another one we've got is Face Grid, and it lets you draw the grid.
This is for the lazy people.
Oh, I don't know. I think it's quicker to do the other one.
Yeah.
But this one, as soon as you enclose a quad, it's going to make a face. Like so. And when I right-click to finish the command, it trims off the extras, and there you go. And you can see that it's also snapped to the reference mesh. And we can tell it's snapping to the reference mesh because the vertices are magenta colored. Okay, so let's try another one here. And that's wraparound. This one we developed for things like, well, typically this handle, so I'll do the handle first. And we aren't really telling it where we want the guidelines, but we're just giving it an idea of where it needs to go. So I do my first guidelines, and then I tell it where I want to cross, and it generates
Rotate, yeah, there you go.
the rest of it here.
So notice that it wrapped all the way around the whole handle there.
And we can control the number of columns and number of rows. So it doesn't really matter where the guidelines are put. In fact, as long as we have a minimum of 2, wrap around again. It's going to fill it in for us. So now the first one you saw where I was adding it by hand, it wasn't very even. So I'm going to sort of mess this one up to show you another great tool we have. And I want to switch into vertex mode. Well, the problem with vertex mode is as soon as I click the vertex, then I have to move my cursor over here to catch the triad so I can move it. And I'm kind of lazy, so I thought, well, you know, we really need a way to do that quickly. And what we've got is we've got quick move mode. And when we turn that on, we establish the transform axis by moving the selected one. And then after that, every time we click, we're using that same axis. And because it follows the reference mesh, because these vertices are staying snapped to it, it really doesn't have to be an accurate axis that we're using. So I'm going to mess these up a bit. Okay, I'm going to mess them up a lot.
This is what mine would look like if I had created it.
Yeah. And one of our favorite tools here is sub-D Smooth. And what it's going to do is it's going to relax the vertices out, and we're still staying constrained to the reference mesh, and even it out. So that's one of the ones we really like to use a lot. Now, those of you who've done some sub-D may notice that we're using the control mesh display mode. We're seeing the flat faces. And you might say, well, wait a minute. If we look at this sideways, how is it that we're seeing the faces when the reference mesh actually pops out above there? And that's another one of the adjustments we have that you can use, and that is in, if you go to Tools, Power Surfacing, those of you who are using SolidWorks 2015, they've moved our tools into a submenu. So Power Surfacing, and then we go to Options, and what we've got is something called Reference Mesh Pushback. So if it's all the way to the left, you're seeing it how it actually lays on the mesh. And that's actually good if you're going to do retopo and not use our shrink wrap option. And then we can adjust it. If you go too far, you're going to see that the sub-D is always shown before the reference mesh. So I usually like to run it about, depending on the mesh I'm using, somewhere about maybe there. And that's something that can be adjusted at any time. So I'm going to close that. And the next thing I want to show you is how we're going to snap this rough control mesh to the actual reference mesh. Or not snap it, because it's already snapped, but how we're going to shrink wrap it onto it. So I'm going to close this file, and I'm going to load up another one. And once again, I want to bring an OBJ in as a reference mesh. We're going to choose the Panther. Now this is a scan, but it's a very clean scan, so you'll see that when it comes in. And we're just going to do a very small amount of it because when you're going for accuracy, it's going to take a lot of time to calculate everything. But you'll get the idea here. So we're waiting for Panther to come in, and here he comes. And you can see the detail he's got on him. And you can see also how clean this scan mesh is. So there's a lot of cleanup involved. But we're going to go and we're going to do some toes. So I'm going to right-click and get my favorite Draw Edges tool. And I'm going to draw a few. And I'm just going to go for the deep parts of the model. So I'm staying in between the toes here. And this is about as many as we're going to need. Let's do one more here. Right-click to finish it. And if we were to rotate it now, you'll see that it looks like the control mesh is way inside the reference mesh. You have to remember, though, that I did put these points down in the valleys between the toes. If we showed you the sub-D version, it would be even further back. And so that's what we need to do, because the sub-D is what you get when you do the conversion into the CAD side. So what we've got now is we've got this add interpolation. And this is just one of the workflows that you can use with the retopo. This is the one that you want to use if you want quite a bit of accuracy. So I'm going to click on Add Interpolation. And under the hood, it's just subdividing it and snapping those new vertices to the mesh. And you can see now it's following the mesh a lot better. But it's still a little ways off. So I'm going to do one more subdivision over here on the left under Command Options. And I'm going to put it up at 2. And you can see now it's even a lot more accurate. We're starting to see the toenails a little bit. But this is where we might want to use the distance display. And so I turn the distance display on. I usually want to recalculate. And this is going to show me my, my difference between the reference mesh and my sub-D. Red is where it pops out above it. Blue is where it goes in, underneath it. And we've got 0.06 and 0.07 inches, because I guess I'm in inches here. So you might decide that's accurate enough. Or you might say, well, you know, I want one more subdivision level. Now, 2 levels is usually going to be the most you want, but there might be times when you want to do 3. And this, by the way, when you're adding these subdivision levels with the interpolation, that's usually the last thing you'll do before you convert to the CAD object. So I'm going to do one more. And you can see this one's going to take a little bit of time, and this is just on a very small piece of the mesh. And when it's finished, which it is now, I'm going to recalculate, and now I'm down to 0.05 and 0.03, so I'm a lot more accurate. And I could accept this as it is, or I might go back, and there might be places where you could add just maybe a couple more edges to get more accuracy. So remember, blue is where it's below the mesh, and red is where it pops out. And if you really want to see how accurate it is, I'm going to, I'll turn off the distance display. And if I turn off vertices and edges, now you can see why we call that shrink wrap, because it's just sucked it right down to that reference mesh. And at this point, we could accept and do our conversion. And here's our 3 little toes, like so.
These little piggies.
These little piggies, yeah. Okay, so now so far you've seen 2 really nice clean meshes that we're using as reference meshes. So this time I'm going to bring in something that's a little more typical of a scanned mesh, especially if you had to do the scanning and didn't have someone else already clean it up ahead of time. So I'm going to once again go to reference mesh, and I'm going to choose the Naboo Fighter if you're a Star Wars fan. Yeah. And I'm going to bring this one in. OBJ files don't have a concept of units, but they do have the numbers, so I'm going to say this one was maybe centimeters, thinking that it was model. Now here we can see already that here's some of the problems with the scan mesh. It's, you know, it can be pretty rough in places. If I zoom this one out and then zoom it back in, we're going to find another problem in that anyone who's done any kind of sub-D modeling, well, actually almost any kind of modeling, knows that it's a lot easier to do when things are orthographically aligned. And if I go into my top viewport, we can see that this one is definitely not orthographically aligned. So one of the things we've got in for helping you prepare your reference meshes is an edit reference mesh mode, and we have some tools we can use with that. And one of them is we can select a face. Now these are really little faces, so you'll just see that I've selected it from the triad. And if I switch over to orient the triad to selected geometry, in other words, local, and I tip it, you can see, oh yeah, okay, that looks much better. So that's going to give me something I'm going to reference on to try and align it to the world plane. So from the right-click menu, I'm going to choose rotate the selection so it is parallel to the selected plane. I choose that guy, and then I want to align that one to the front plane. You'll see it move here in a sec. And there it's aligned to the front plane, but while we're there, I'm also going to center it to that same plane. So center it to the front plane. It's going to jump forward, so I'll roll out a bit. And if we turn on the top plane and the right plane, now we can see that it's pretty much spot on to where I chose that face to reference from. Now at this point, I'm going to turn off top plane and so I'm looking down on it. And now we can see, well, you know, it was kind of close, but not that close. And when you're dealing with scanned meshes, they're neither going to be perfectly aligned or perfectly symmetrical. But you know, if you can get it closer, it's going to make your life easier. So the next thing I want to do here is I'm already in Edit Reference Mesh, and now I can select the reference mesh, and I'm going to rotate it. But as a default, just like SolidWorks itself, we have snaps that are automatically working. So I'm going to go over to my regular Power Surfacing tab, and under Advanced Triad Options, I'm going to turn off Rotate Snap. Now I can grab the rotation part of the gizmo and I can move it around. Now we aren't going to see it update in real time, because if you had a huge reference mesh, there'd be too much leg. So as soon as I let go of the mouse, it's going to update. And I could go a little more than that. And there I went a little bit too far. But the other thing I can do is I can go over to my Advanced Triad options, and I can say, well, you know what, let's just try 0.9 on that. So enter. Let's see. Oops, wrong direction.
Because you're negative.
Yeah, I'm already negative. Okay, what was that? I can't remember. 7 was it?
Yeah, try 0.98 or 9.
Yeah, we'll try 0.8.
That's probably still.
Enter. Update here. Am I still going the wrong way? Okay, I can.
No.
Okay. So anyway, you can, if you can decide where you want it to be. Actually, I think it is.
Yeah. You want it left.
Okay, it is updating still. I may have lost it here. Yeah, I think I've killed it. Not sure how. Probably just being impatient. So anyway, this point, the other thing you can do, and I'm not going to show you just because it seems to be waiting for me, and I'll probably just close and restart just to make things quicker. But the other thing you can do is you can select parts of this and you can delete them. So if you had a really bad bubble where it didn't scan well, you could delete it. Or say you've got something like this dome on the, I don't know what that is, probably some little guy with a weapon in there. But you could delete it and do your retopo and then add that part back in with a SolidWorks feature, which is going to be a lot more accurate. So, okay, so let's kill this off. Oh, I think it's really dead. Ooh, wait a minute. I think it's finished. No,
Yes.
It's not. I think I'm finished. Let's see. Close.
There at the bottom. You can go to the task manager and kill it.
Yeah, I think I'm going to have to control it. Yeah, this didn't happen in all my practices all week, so I don't know what its problem is.
That one, yeah. All right, start it back up.
What are you guys seeing now as far as the screen? Yeah, since I had it locked on SolidWorks and I just killed SolidWorks.
We see the blue.
Do I need to?
Do you see SolidWorks again now?
No.
Okay.
Okay, let's do it right here. Go to that one. Choose that right there.
There we go. Okay.
That should be it, right?
There it is.
Yeah?
Yes. Yes, you're back.
I apologize. Apologies. I probably pulled something too fast and too hard. That would be me. Okay, so I'll just open that one and just show you the little bit more I was going to do. So once again, reference mesh model, bring in the Naboo. And and I'm not going to align it again because you guys have already seen that. So here's something where we can get rid of a bump or something. And actually, I'm going to do just the opposite. I'm going to show you how to pave over a hole. Because now if we look at the underside of this, you can see that scan was pretty messy. And you aren't going to want to pave over something that's this messy, or it's going to cause you problems. So what you can do is you can make a patch or a Band-Aid that covers up some of these really bad spots. So I'm going to use my Draw Edges tool. And the first thing I want to do with that is set transparency so I can see where the hole actually is. And I usually like to set my transparency to about 50. And what we're going to do is we want to have a nice smooth patch that's going to follow the contour. And the way we do that is we can subdivide, not subdivide, but we can add more edges, subdividing in one direction. And see here, because these are constrained, and we can tell they're constrained because they're magenta colored, they're following that contour. The problem, though, is as soon as we go the other direction, you can see they're going to snap to the closest surface they can find.
Which is in the hole.
Yeah, which is in the hole or on the edge or something. So there's something we can do for this. So I'm going to cancel this. And what we want to do here is we want to go down and turn off the constrain to mesh mode. So that's off now. Now I can go in and add my edges the other direction, like so. And they're not getting snapped, so they're kind of straight across. If we look here, you can see them kind of going like that. And now, before we reconstrain, I'm going to bump up the resolution on this and subdivide it once. And then I'm going to select inner section, and I'm going to set these vertices to unconstrained. And I click that. Here's in my right-click menu. So I unconstrain them. And if I click outside here, you'll see now that they're black. So remember, magenta is constrained to the reference mesh. Black is not. Now it's safe to go down, turn on constrain to mesh again. And we won't see anything happen until it to update. And we do that. Oops. Oh, this is not good. I hate it when I do that. Come on, go back up there. We do that with the snap vertices to reference mesh. And you may not have noticed that, so I'm going to turn off transparency. But now you can see we've got this little ledge here. So the goal here is to take the unconstrained vertices and interpolate the curvature to match the rest of the mesh. And we can do that. We can easily select those by using another quickie command here, which is select constrain. I'm going to switch to face so you can see it better. It not only selects constrained, but unconstrained. And I'm going to select the unconstrained vertices here. And I'm going to move this off to the side so you'll be able to see it when it happens. So now we're going to use a tool from Tools, Power Surfacing, Specialized Tools, and this is Curve Selected. And as soon as I click that, it pops out. You may or may not have noticed. But now, if I look at my side view, you can see that the curvature is pretty much continuous with the model in both directions. This is a very powerful thing. So it gives you the chance of repairing a lot of stuff without having to eyeball it. Now you might say, okay, well, it's still a sub D. How do we turn it into something that's part of the reference mesh? Well, that's the next step. And we select the entire piece. And right up here on the toolbar, we have Add to Mesh. And it looks like it disappears, but remember there was a hole there. And if we tip it to the side, you can kind of see the original quads in there. I could have bumped it up higher, but I think this is probably plenty accurate for this particular model. So that's one of the very powerful ways of preparing your mesh before you actually do your retopo. And then I'll go ahead and I'll get rid of this last bump up here. That sort of segues into our next feature for prepping the mesh. So I'll take this guy, and I'm in Edit Power Body right now, so I need to return to Edit Reference Mesh. And I'm going to select bump. And from the Power Surfacing menu, I'm going to open up our Selection Set Manager. And this thing's pretty cool because it's going to let you separate things out and hide them and show them at will. I mean, we could, because we're in Edit Reference Mesh, we could delete this, but you might want it back at some other time. So what we can do instead is we can add this selection, Here it is right here. You notice there's already one in here. Well, that's that curvature Band-Aid we added earlier. So anytime you add to mesh, it's automatically going to create a selection set for you. So this one's now in here, and at this point I can uncheck it and turn it off.
You can also name those selections.
Yeah, well, so you'll see them named in the next section. So anyway, the thing is that if the mesh is not showing, nothing gets snapped to it. So you kind of get the best of both. You don't have to delete it, but you can hide it so it doesn't interfere with anything. So I'm going to close this and get out of my edit reference mesh. And I'm going to bring in another file now that's already been prepared, and it has all selection sets, and you'll see one of the other cool things we can do with it. So we're going to open, and this time we're not going to open an OBJ because the OBJs don't have a concept of selection sets. So we're going to open a P model scene, which is basically the reference mesh that I'd added my selection set to and then saved out as our native format. So we'll open the detergent bottle, and here he is again. But this time, if I open my selection set manager, not a sub D, it's a reference mesh, so there it is. So I've already created my selection set, and I can go in and turn them off and on at will, and you're going to see why this is really cool in a minute. So I'm going to turn off the base, that's the part down there. The top shoulder, that's these two parts, you can't see yet. Here's the sides, so now they turn off. Lower body, I can turn off the handle. Well, I don't need most of that stuff off, so I'll turn some of it back on. But now what I can do is I'm going to go over to my Power Surfacing RE tab, and I'm going to use wraparound, and I'll just make a really simple wraparound here if I go slow enough. So, cross member, and then I'll turn my number of rows down, and I'm going to bump up the number of columns so you can see what happens. Okay, so right-click to accept that, and I'll select all my lower edges. I've double-clicked near the end of a loop, and that's going to automatically select the whole loop of edges. And what's going to happen is now when I pull down, because there's nothing beyond this as far as the retopo is concerned, it's going to stop at that edge.
So it essentially snaps to that edge.
It doesn't snap there, it just stops.
Essentially,
yeah.
That's what
and what this does is now I can right-click and go in and say, okay, let's make this a hard edge. Now, if you're just making monsters and ogres and things with sub-Ds, you probably have very little use for a hard edge. But when you're doing more industrial sort of design and things, a hard edge is something that's a big part of some of the design. So having done that, now I'm going to turn on the lower body, and holding my A key, I'm going to do a little bit of an extend. Now notice that these guys did not automatically constrain. That's because there's a lot of times when you're going to want to add more to the mesh without letting it constrain. So I need to right-click, and I'll set these to constrain. Now they snap right in. And now I can finish pulling this extrude down. And just like before, it gets down to a hole, and it stops. So once again, I'll go ahead and set my creased edge, and now I'll turn on that last bit, that selection base, and I'll use one more tool that you haven't seen yet, and that's the Smart Fill. And now it's filled up. We're good. It's a pretty coarse mesh, so you can see it's not following the curvature here. I could either add another subdivision if I wanted, or I can go back and I can use my add interpolation. So I'll use add interpolation. We can see it pops out to the mesh. We've retained that nice hard edge, and I'll accept that and convert to the CAD. So this is something you aren't going to see in a lot of products, this ability to retain or to create a hard edge on a scanned mesh. That's one of the things we like to use.
Very important for mechanical shapes.
Okay, so the last thing I'm going to show you is another method of matching the mesh. Close this guy. And I'm going to bring in another P model because it's sort of already partly made. And this time, a P model can contain both the sub-D and the reference mesh, so it's a handy way to save it inside of your regular SolidWorks file as well. So I'm going to bring in our Naboo fighter again. And this time, I've modeled the fighter pretty much with just the sub-D using the reference mesh as a template. And you can tell I haven't snapped it down yet because my vertices are still all black. Now I could set them to constrain. Right-click menu. You can see them, they popped in a little bit. And I can go ahead and I can use add interpolation. It'll pop out in a minute. But if I go in here and I look closely, some of it's okay, but I've got a little problem here. And this is an indication that I need a little bit more geometry. So I'm going to cancel the interpolate. And right now it leaves it in sub-D, so it's looking sucked in. By the way, that's one of the options, is you could model in sub-D and just match the mesh as a sub-D. That way you wouldn't have to use interpolate. You wouldn't get quite the accuracy, but sometimes it'll give you a lot easier ways to do more manipulation and modifications. But this time, though, what I want to do is I'll switch back over to control mesh, and in edge mode, if I hold my A key down, I can add edges, and I'll do that on the other side as well. And it'll help get around this tight angle I've got here. So now, if I do my add interpolation,
by the way, she could have done that with a mirror, but I don't think she has mirroring turned on this model. Right?
No, I don't. No, because with a scan mesh,
it's hard to align it.
Yeah, it's probably not going to be totally symmetrical. But there's no reason why you couldn't use mirror on it. So anyway, adding those 2 extra loops has now enabled it to get into that tight angle there. So we'll accept that and convert. And that's pretty much all I have to show. So Dave, do you have anything you'd like to add, or we could ask for questions?
No, I was going to ask you to show the autofill, but you kind of did that with the
yeah, I did that one
with the bottle. Are there any questions out there?
Well, there's just one question that came in just at the beginning. Is there a series of beginning videos on how to use a power surfacing program? Do you guys have anything?
There are.
Good.
There are videos on, and they go from the introductory to the more advanced, and they're available on our webpage. If you click on the tutorials link, you can find those video tutorials. There's a whole series of them.
I just realized I forgot something important about this method. Yeah, I sort of forgot I forgot the main part of this method, and that is how I started this model. I knew I was going to forget something. So let me hide this as it stands. And what you can do is, if you've got a complicated model, you can start with a bounding box around it. It's usually when I have control mesh. And what that lets you do is set up for your modeling and just block it in. So you're kind of making a low poly proxy mesh. And the advantage in a model like this especially is that everything's going to be connected. And that's one of the things that's kind of difficult if you do some of the more manual creation methods. Sometimes if you work on this piece and you work on this piece, it may be hard to connect them up because the edges don't line up. They don't line up, but they might not be the same number on each side. And this method allows you to do that. And then you just do extrudes and manipulation of the vertices, just like regular polymodeling. So anyway, that's the one I forgot to show you. All right, I'm good.
Okay, then I can ask you while you're there. While you're there, I will ask you another question. Can you? Somebody's asking, can you zoom in on the edges of the Nabu fighter?
Go ahead and zoom in, please. Is there something in particular you wanted to see with the edges, or?
Well, we don't know. That's a good question. Let us know, Matthew, I think. Let us know if there's anything in particular. In the meantime, we can answer to another couple of questions. And one is, there's a few people that want a clarification about power surfacing reverse engineering, and they want to know if it's a standalone included in power surfaces or it is an add-on. I think
that's a good question.
Yes.
It's actually sort of an extension of power surfacing. So it includes everything in power surfacing, and it's an additional set of features that are available on that RE tab. If you look at her screen, you can see a power surfacing RE tab, and that has all of the RE tools, which are in addition to the power surfacing tools.
And you probably noticed that I did go back and forth. I did use some of the regular power surfacing tools, especially some of the dialog menus and things.
And as far as being standalone, I'm not sure what they mean by that, but it does run inside of SolidWorks. So it's a plug-in for SolidWorks.
Yeah, great. So guys, if you want to get it, you can come to Novedge, and it's I'll show you the page shortly. And another question is, are there any tool sets in power surfacing RE present in power surfacing?
Well, yes, the power surfacing RE contains all of the power surfacing tools. So yes, it does, not just some, but all of them. All of the power surfacing tools are available in power surfacing RE. And
is RE a new release or is it an update?
It's essentially a new release. It's a new product based on power surfacing.
Okay. I think we answered all the questions yet, and we didn't get any other explanation about why Matthew wanted to zoom in on the edges. But I think that was quite satisfactory for him, I'm guessing. Okay, great. So yes.
If there are other questions, they can feel free to send messages to support@npowersoftware.com. We'd be happy to answer any questions that anyone might have.
Okay. Oh, questions. Oh my gosh. My goodness. Okay. So people are asking if we have a power surfacing. Do we need to purchase RE separately?
Do you need to purchase it separately? Is that what he's asking?
Yes.
You can purchase power surfacing RE separately, or you can purchase, if you already have power surfacing, you can purchase an upgrade to power surfacing RE.
Okay. Will we be able to work with point clouds as well as meshes?
Well, point clouds can be turned into meshes through a number of different tools, but we don't currently import point clouds. But there are lots of tools that will turn point clouds into meshes.
Cool. And what kind of power, CPU, and RAM is required?
That's a good question. Anything that runs SolidWorks fairly well will run this. Will run this too very well. you don't really need anything extra special. We do require a graphics card that has shaders, that support shaders, if you want to use the, the nice shaded images, if you want to use the our shader tools.
Is that also necessary for the distance tool?
Yes. For instance, the distance tool uses shaders. So if you want all of the features to work correctly, you should have a graphics card that supports shaders. All of the modern graphics cards do support shaders, but some of the very older ones do not.
All right. Can you automatically recognize holes, revolves, etc.?
Not automatically in the scan. We're working on some tools to be able to identify features like that, but in a scan, they never come in precisely, but we are working on some tools that will allow you to identify analytic shapes like cylinders and toroids and spheres and etc.
Okay.
But in the current version, it doesn't.
Okay. Is it multi-core?
Parts of it are multi-threaded, yes.
Okay. And one final, yes?
The high computational pieces are multi-threaded, yes.
Great. Is there classroom, somebody is inquiring about classroom training.
We don't have an established training program really for in-class training, but we have done training for people specifically by, on request, so.
Okay.
It's always a possibility, yeah. People, of course, we're going to charge a little bit for that, but.
Okay, yeah,
we've
seems
been
fair.
Train people to help them out.
Great. So reverse engineers' primary use is for scans, right? That's what they're asking.
Correct.
Okay. And what is the planning for analytical shapes?
Well, we're working on it.
Okay.
The plan is.
No, I think what you're asking is, can we use a SolidWorks shape as a reference mesh? And we can. In fact, I'll show you that real quickly here.
Oh yeah, we probably should have showed that.
Yeah. Just do a new.
See, these are great questions.
Yeah, they are very good questions. We've got a good audience.
So if I start with a sketch, right out here, and
so I think she's just going to create a cylinder or something in analytic shape, right?
Yeah. Mm-hmm. Yeah. So features, extrude, okay, so now there's our shape. And what we can do then is, from the power surfacing menu, we can create reference mesh from selected body. Oh, that means I have to select the body first.
Yes.
And I think we want to hide that one as well before we do that. So I'm going to hide it and then keep it selected, and then power surfacing, create reference mesh from selected body.
Why did you need to hide
and there it is, because otherwise it would be showing at the same time.
Okay, because they overlap.
Yeah.
Okay.
So there we go. So you can take any SolidWorks body and turn it into a reference mesh for retopoing as well. So that's one of those.
Including multiple surfaces.
Yeah,
right?
yeah, and that's one of the important points there, is you could use multiple surfaces, like some of those race cars would have been a lot of separate surfaces, and when they bring them all in as reference meshes, then your sub-D can pave across them and simplify it by turning multiple parts into a single part, which is really nice.
Mm-hmm.
So.
Does
that answer the question?
Perfectly. I think Sue is my mind reader. She knows exactly what art and D meant. But they're asking, is that a sub-D cylinder now?
No. Right now it's a reference mesh, as if it were scanned, in other words.
Okay. So I have one question. Yes.
Okay, so in fact we could do it really quickly here. Let me, I'll delete this and I'll use wraparound on it. So let me get to a nice side view. And over in RE, do wraparound. I'm a little crooked there, but I'll come out in the wash. So we can pull this thing up, and I think it's going to stop. Yeah, so it'll also stop. I didn't hide the bottom faces, but because it's a good 90-degree angle, it stops there. And then we'll do add interpolation.
So there it's a perfect representation of an analytic cylinder.
Well, not
without,
perfect.
well, no, without the top. But the side,
yeah, okay,
but the side part is a perfect representation of the cylinder in sub D.
Smart fill. Oh, I should have made that a hard edge before.
I got to crease it first, but
yeah,
that's okay.
I can do that. So hard edge, and then smart fill. Okay, I'm forgetting something here, I'm pretty sure.
Yeah.
Oh, I know, because we're seeing it in sub D right now. Okay, there we go. And I'll leave the bottom open, but now if I do add interpolation, there it goes. So there it is, cylinder, sub D, and the advantage, of course, is that you could tweak it as well.
Yeah.
Okay.
And
any other questions?
Yes. So is it possible to import a mesh from, say, ZBrush and use it as a reference?
Yes.
Absolutely.
Yep.
Yeah. Mm-hmm.
We have customers that do that. So.
And also have another question that goes like this. Our 3D scanner captures the surface textures as we scan, and we apply that texture to the mesh. Can power surfacing translate that texture to the surface body in SolidWorks?
That's a good question, and currently it doesn't, because we don't really, there isn't a kind of a standard representation for those textures. So,
and that would be on the reference mesh.
Yeah, it's not stored, I don't think, in the standard OBJ format. So,
well, no, because OBJs have materials. OBJs can store materials.
Does it have the texture though?
Oh, the texture itself, no, it wouldn't have that. You'd have to assign it, but I think it at least saves the material ID.
The material we could bring in, but not the texture, at least not currently.
Okay, well,
that's a very good question.
Yeah, I'm telling you, these attendees know what they're talking about, and I think you did a great job addressing all the questions. Everybody's happy. So I will have to take the screen back. I apologize for that. My screen is not as exciting as yours, but still, I hope you can see it. I'm back, and I would like to thank everybody for attending this webinar. And I want to remind everyone to visit our page at novedge.com, where you will find Power Surfacing 2.0 waiting for you. And Novedge is the best way to buy design software online. For information on the latest special and new releases, join the Novedge network on Facebook, Google+, Twitter, and also check out our Novedge blog. Our upcoming webinar next week will be on Atlantis 6, which is a 3D rendering application developed especially for architects and designers. And to watch today's webinar or previous one, check out our Novedge YouTube and Vimeo channels. And somebody was asking, is this webinar, we want to watch it again, we have to leave. So go to our YouTube channel and Novedge as early as this afternoon, and you will find this webinar there for the years to come. Okay, thanks again for joining us, and have a wonderful day. I want to thank you, Sue and Dave, for a very entertaining and interactive presentation. I love your chemistry. It's always fun to co-present with you. And goodbye, everyone. See you in the next webinar.
Bye, all.
Bye, thank you.
Bye-bye.